Hi, I'm Tinny from Mini Bowl Design, and today I'm out here in the dooryard at about 30 degrees, 28 degrees, performing an experiment. I've got a MSR Titan kettle here that we were boiling some water in earlier, and I'm going to leave just a little bit of water in the bottom of it, and then I'm going to fill it up with snow. There. Now I've got a stove in here that I've designed to melt snow. Now the biggest problem with melting snow with an alcohol stove is when you set the pot on, the stove goes out. So this stove I've designed, hopefully, and we're going to test it here in a minute, to see whether it will tolerate this cold pot without going out. So let's go in and take a look. Okay, I've made this BIOS taller so it would hold more alcohol for extended running for melting water, for melting snow into water. I put a regular wick on it. Then on the top, rather than crimping the edges like I normally do, I free-ported it inside so it couldn't boil over. Then I put it on the lathe and turned down both sides of the edge till it was razor sharp. Not razor sharp, but sharp. Not sharp enough to cut you, but up to a sharp edge, like a dull knife. Then I relieved also about 4 places, so I have 4 places that are raised up that are very, very thin, very low contact area. Now the reason I've done this is the less contact area you have between the pot and the stove, the less chance you have of the pot sucking all the heat out of the stove and making it go out. That's what makes stoves go out when you put cold pots on them. So this having a very minimal contact area, theoretically it should work great. Now I'm in my shop here, which is about 28-30 degrees in here, and I've got the light on. So I'm going to light this, and as soon as I get it lit, I'm going to turn the lights out so it'll be really dark in here so you can see the flame. And Robert's running the camera. He's going to get down here, and we'll put the pot on and see what happens. While I'm getting the light, we'll let this preheat and blossom out. Now I'm not going to put the pot on there until the wick goes out, because that wouldn't be fair to test it with the wick preheating the stove. So I'll let the wick completely go out. I primed it pretty hard. And then we'll see what we got here. Come on, wick. Okay, the wick's out now, and we've got just a standard tall BIOS stove. And here's a pot. There's about a ½ inch of water in the bottom of it to make sure that the snow doesn't cativate up and get away from the bottom, so we've got a good cold bottom. And let's set it on here and see what happens. Well, it didn't go out, but it certainly did have an impact on it. So I'm going to say that's less than 100% successful. In fact, it sucked enough heat out of it so it's having a hard time getting back. So I'm going to keep working on this design, and when I get it perfected, I'll let you know. Okay, this is try number 2. I adjusted the surface area and really paid attention to how much surface area I have. So we'll see how we do this time. Theoretically, there should be so little surface area that it couldn't possibly transfer the heat up to the pot. We'll let that preheat, and I'll go turn the lights out so we can see the flame rolling off. Once again, we'll wait till the wick burns off so it's a fair test. Okay, the wick's burned off. We've got our MSR Titan kettle right full of snow, and there's a little bit of water in the bottom. And we'll set it on here and see what happens. There, that's what I was looking for. Had little or no effect on the stove. And I think this would be a good stove to melt snow with, because you can put about 3 or 4 ounces of alcohol in it. So, I'll keep working on this, and if I figure it out completely, I'll put one in the store, and so you guys can have one. I'm Tinny. Bye-bye.